Today we're starting Chapter 5, Analytic Trigonometry. And we're going to continue working with our trig functions, only we're going to really be looking at them in a different way this chapter. Now, Section 4.1 only has one objective, and that's to be able to verify trig identities. We'll talk in a minute about what that means to verify an identity, but first, I just want you to pause your video and take a second and review the identities that are listed on the right side of your screen. Now, you have all those identities already somewhere in your notes. They're also on page 570, and I expect that you are able to recall these at any given second. So these are identities that you really need to know always. So go ahead, pause your video and review them. So now, we're going to go ahead and take a look at our first verifying the identity question. You'll see right now that I have on the screen secant x cotan. The secant x cotan x equals the cosecant of x. Now, there's a few things to be really cautious of on these verifying questions. The first thing is because I'm verifying it, I don't actually know for sure that these are equal. Now, it's telling you they're equal, but I'm verifying they are. I'm making sure that they're equal. So one thing to remember is that this is not an equal sign that you can do something like add to both sides, or subtract from both sides, or multiply from both sides. You can't solve this like you would an equation. What it means to verify means to take one side and make it look like the other. Turn one side into the other side. So, some ideas on where to start. The first thing when you're verifying is I would pick the side that's more complicated. That's one good way usually to start. Start with the more complicated side. Now when I look at this, I see the more complicated side over on the left. So I'm going to look at the left side of the equation. Now, I'm going to draw a line here because I need to remember that I don't want to do anything to the right side. I am only going to look at the left side. So I'm going to ignore the right side for now. This cosecant of x is not going to change. And let's just take a look at our left side. Now, when I look through there, I have secant x and cotangent x, and I'm trying to turn it into just cosecant of x. That's my goal. I'm going to go ahead and look to see if there's anything I can change. Right now, I know that secant of x is the same thing as 1 over cosine. Secant of x is the same thing as 1 over cosine. So I'm going to replace secant of x with 1 over cosine of x. I'm going to just go ahead and switch those around. The other thing I'm going to do is I'm going to change cotangent of x. And I have a couple options here for cotangent. I can change cotangent to 1 over tan or sine over cosine. Now, or cosine over sine. Let's go ahead and try cosine over sine. Remember, the goal in the end is to get to cosecant, which is a reciprocal of sine. So I think I need a sine involved somewhere, so that's why I'm going to choose cosine over sine. So I'm going to change cotan of x to cosine x over sine x. And now I'm going to multiply. When I multiply straight across the top, I get cosine x. When I multiply across the bottom, I get cosine x sine x. And the great thing now is those cosines are going to cancel out, and I have 1 over sine. 1 over sine x, that's the same thing as cosecant x. And that's really the goal. That's what I was looking for. I was looking to turn it into cosecant of x, which I did. So I can say, yep, these two things are equal. And I just proved or verified that that's true. All right, let's try another verifying the identity. You can see quickly before I switch sides that the most important thing I did was replacing. I replaced functions I knew with other functions. So I went in ahead and I replaced ones I knew with others. All right, here's another one. Sin x tan x plus cosine x equals the secant of x. So, once again, one thing we like to do is start with the harder side, and I would say the harder side is the left side here. So I'm going to just draw a little squiggle. Remember, my goal is to make it look like secant x. I don't want to touch secant x right now. I don't want to move things on either side. This isn't an equation to solve. We're verifying this is true. We're making one side look like the other side. So now, let's see what I know. I'm starting with sine x times the tangent of x. And I know I can switch tangent of x. I can either switch it to 1 over cotan or sine over cosine. And I think that it's better if I have all sines and cosines. So let's switch tan x to sine over cosine. So right now I'm going to have sine x times sine x over cosine x. I changed tangent to sine over cosine. Plus another cosine x. The only thing I've done so far is switch that tan x to be sine x over cosine x. I'm trying to simplify this as much as I can and get it down to one thing. So I'm going to have to do some multiplying over here first with the sine x and the sine x over cosine x. I'm going to rewrite this as sine x over 1 and multiply across the top and across the bottom. So I'm going to get sine squared x over cosine x plus, and I'm going to rewrite this as cosine x over 1. It's the same thing. But I see that I'm going to have to add some fractions here, right? We're going to have to add some fractions. In order to add these fractions, we're going to need a common denominator. Well, the second fraction is missing a cosine x in the denominator. Then they're the same. So I have to put a cosine x also in the top. And remember, that's multiplying. Now that I have common denominators, I can go ahead and add straight across the top sine squared x plus cosine squared x. And remember, when you're adding fractions, you add across the top and the denominator stays the same. So now I have sine squared x plus cosine squared x all over cosine x. I'm trying to get to secant. And I hope at this point, since we're trying to get to secant and we have cosine in the bottom, you're thinking you're close to having the reciprocal of secant, 1 over cosine. We're close to the reciprocal function there, 1 over cosine. So now I need to think about this sine squared plus cosine squared. Well, sine squared plus cosine squared looks familiar to one of these Pythagorean identities here. Sine squared plus cosine squared equals 1. So I can rewrite that top as 1. On the denominator, I have cosine x. And now 1 over cosine is equal to secant. Secant is 1 over cosine. And so now I have secant x, and that's in fact what I was trying to verify, that it equaled itself secant x. I want you to pause your video, and I want you to go back and think through this and make sure you understand every step that I just did. If there's a step you're not sure where something came from, I want you to take a highlighter and highlight it so you remember to ask me in class tomorrow. We're going to verify one more identity today. So we're going to do one more of these. So let's go ahead and bring up our last identity for today to verify. All right, so cosine x minus cosine x sine squared x, and I want that to equal cosine cubed x. Remember we said to start with the more complicated side, and to me that looks like the left side over here, the left side. Now, the first thing I want to do is see if there's anything I should swap out, see if I should make any changes. The problem is right now I'm all in sines and cosines, and I'm trying to get it to equal cosine. So I don't want to bring in any reciprocal functions like cosecant or secant or cotangent. So I really probably don't want to be doing any switching right now. I also don't see a Pythagorean identity, so I can't do anything there with those. So now I'm going to just think back to my algebra for a minute. I notice that both pieces here have a cosine in them. When two things have, when a binomial has two of the same things, remember we can factor it out. Look for a minute up here. If I have x times xy, and we'll say y squared, x times xy squared. Remember that if I have two pieces the same, I can bring them in front. I'm going to be left with 1 minus y squared. I can factor that x out. I'm going to do the same thing with cosine. I'm going to factor cosine out. I'm going to pull cosine out in front. I'm going to be left with 1 minus sine squared. Now don't forget where the 1 comes from. When I take cosine in front here and divide it by cosine, I'm left with 1. If you're not sure, distribute it back in, and you'll see you get to where we started at the top. Now, how does this help me? Does it get me anywhere else? I see a 1 and a sine squared. So I'm thinking that kind of has the pieces for one of my Pythagorean identities. If I look over here at this Pythagorean identity, sine squared plus cosine squared equals 1. If I subtract a sine squared from both sides, I'm left with cosine squared equals 1 minus sine squared. So cosine squared is the same as 1 minus sine squared. I'm going to replace my 1 minus sine squared with a cosine squared because of that Pythagorean identity. And now 1 cosine x times cosine squared x gives us cosine cubed x. Just think of it as x times x squared, that equals x cubed. And that's in fact what I wanted it to equal. So I just proved or verified that that identity is true. Cosine x minus cosine x sine squared x does in fact equal cosine cubed x. So, some guidelines for establishing or verifying these identities, some things that you should have noticed. In these examples we just looked at, we always started with the more complicated side. We rewrote sums or differences as a single quotient, meaning adding fractions. We added fractions together when we could, or multiplied fractions when we could. Notice we wrote things as sines and cosines as much as we could. And we also factored. These are some of the things that'll help you. Now notice you won't always use each of those every time. But we can't ever be afraid to start over or forget what our goal is. We can't forget what our goal is. We always have to keep our goal in mind. Where are we trying to get? Every time we practice these, we're going to continue to remind ourselves of the guidelines to help us. And that's it for today.